Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Welcome friends to the next lecture on maritime structures under fire, blast and explosion loads, which is offered by the Department of Maritime Engineering at IIT Gandhinagar under SwayamPrabha program. Maritime structures under fire, blast and explosion is coordinated by myself and Gaurav Srinivasan, head civil engineering, and myself Chandrasekaran, head maritime engineering, both at IIT Gandhinagar. Friends, welcome to the fourth lecture on this course and the sequel lecture on coastal structures 2. In the last lecture, we discussed about different types of coastal structures. They are important because they are main sub-segments of maritime structures. So before we learn to understand the structural design of maritime structures under special loads such as fire, explosion and blast, we must understand first the classification of these structural systems, materials for construction, their choice of construction, the cross-sectional properties and the stiffness and flexibility requirements of the design, etc., before we learn more about repair and maintaining these structures under these kind of loads such as fire, blast and explosion. So, welcome to the lecture 4, which is continuation of the previous lecture, coastal structures part 2. In addition to what we discussed in the last lecture, we now continue to take it forward to discuss another type of structure called bulkheads. The name itself is very clear that there is a massive structure which is standing in the forefront of the coastline, essentially to prevent landslides near the shore. They are usually constructed near harbours and marina areas to protect the harbours and marina areas from landslides and severe soil erosion. The primary action of this structure is to protect the shoreline from landslide. Of course, the secondary action is to protect it from the waves. Essentially, the structural geometry looks that they are vertical in the forefront, vertical retaining walls. One can also have sheet piles or soldier piles on which these walls are resting. These piles and the walls are anchored, connected together with tie rods, and of course, filter cloth and drainage systems are provided to allow seepage of water through them to avoid breakage of these walls under huge impact loads caused by the lateral waves. Bulkheads are essentially soil retaining structures. They are not wave protected structures. The primary action is to protect the soil from landslides. Okay. The secondary action of course is protection against waves. Wave action is secondary, soil stability is primary for bulkheads. They essentially act as soil retaining structures. They resist lateral earth pressure by the geometry and virtue of weight. It minimizes wave disturbance in the harbours. Generally, bulkheads are deployed at harbours, marinas and mooring zones where soil erosion is more sensitive and landslides could happen because of severe soil erosion or sediment transports. Bulkheads protect land locally, but disturbs the coastal habitat very severely. Okay. The next type of structure which is constructed on the coastline, which is groins. Groins, what you see here, are generally constructed perpendicular to the coastline. If this is the coastline, groins are normal, okay, perpendicular. Possibly friends, this is the only type of coastal structure constructed perpendicular to the shore. Okay. Rest coastal structures are generally constructed parallel to the coastline. Groins are essentially trapezoidal in cross section with armoured rubble masonry, which are essentially constructed for an enough length penetrating into the sea, which is normal to the coastline. Okay. The first primitive purpose of a groin is to control long shore sediment transport. As I said in the beginning, if you have noticed in the previous lecture, when sea walls and sea dikes are constructed, there is a sediment transport happening along the coastline. Okay. From one end of the sea wall to other end of the sea wall, sediment gets transported and that weakens the foundation of these sea walls and sea dikes. So, groins are constructed to protect the coastline from long shore sediment transports. Of course, it also reduces beach erosion and it stabilizes the nourished beaches. In most of the cases like Pattaya in Thailand, Hawaii in USA and Dubai, the Golden Beach, all are generally stabilized by constructing groins along them. You will find lot of groins constructed along the coastline especially in Goa, in Marina Beach in Chennai, in Kerala Beach, lot of groins are constructed to nourish the beaches and stabilize them from extensive sediment transport or soil erosion. So, the purpose of a groin is to protect or control or minimize the long shore sediment transport which can happen along the coast from one end to another end. They are usually constructed perpendicular to the coastline. They have a trapezoidal cross section which is rubble mound construction. They are built in series and we call them as groin field. As you see in this figure, there are many groins 1, 2, 3, 4 and so on. The spacing between them, it all depends on technically what is the wavelength and how much the transport sediment can take place, right. And the projection of these into the sea is also not uniform all the time. They can be longer, they can be shorter, right. So, they are all constructed perpendicular to the coastline and they are very effective. They are very effective in controlling the long shore sediment transport along the coastline. Groins are possibly the only maritime structure constructed perpendicular to the coastline, rest of them are mostly parallel. If you look at the structural action of groins, how they actually counteract the lateral loads acting against them, it traps the sediment on the updrift side and reduces the erosion on the downstream side. Okay. These structures are very massive in weight, they have a very low dynamic response. Okay. Groins solve erosion locally, but redistribute the problem regionally. Wherever you have got groins, that area will be protected from shore sediment transport, but the adjacent areas will invoke more severe problems. Okay. So, that is another major issue with groins. As you see, this is most commonly with almost all types of coastal structures. The other one what we are interested in seeing is the breakwater. As you say the word itself, the wave height or the wave energy caused by high amplitude waves need to be broken, because if you allow the waves to pass and touch the beach, then the beach will get soil eroded completely or very badly. So, the amplitude of the waves when they approach the beach need to be reduced. So, breakwaters are those kind of structures which are constructed to reduce the wave energy when they reach the shore. They are helpful in protecting harbors and coastlines. Essentially functioning is to reduce the shoreline erosion. Breakwaters are constructed parallel to the shore, rubble mounded, detached breakwaters. Sometimes one can also construct submerged breakwaters. You can allow the waves to pass through the breakwater above, topple them, they are called reef breakwaters. They also are effective in controlling the or breaking the wave height. They are a massive section with trapezoidal geometry. The landslide, seawater side, okay. They have rubble mounds which are placed in armored layers in between them. Big boulders, so on. Okay. So, rubble masonry construction. These are armored layers. They are constructed for a specific length parallel to the coastline. The foremost purpose of constructing breakwater is to reduce the wave energy. Okay, it helps us protecting the harbors and coastlines. The common material used for constructing breakwaters is quarry run sand. Then it is also reinforced with large size boulders or concrete units. We call them as armor units. It comes in multi-layer system, core, filter armor and so on, as you see in this cross section. Okay, multi-layer, layer 1, layer 2, layer 3 and so on. The primary function of a breakwater is to create calm waters. Once the water is maintained to remain calm, then one can have safe mooring and cargo handling. Therefore, wherever you have got commercial ports and harbors constructed along the coastline in the world, you will generally have breakwaters ahead of these to control the wave amplitude as they reach the harbor. So, that will give you a very safe, calm navigation channel so that one can admit the vessels inside the harbor segment in the basin, and then you can do cargo handling comfortably. If the waves are allowed with the same energy to come and touch the harbor side, then there will be lot of roll and heave motions happening on the vessel, and the vessel is very difficult to get unloaded, or cargo handling becomes tedious and very difficult job. So, you need to have a calm environment along the coastal side, and people construct breakwaters as supportive systems to reduce or break the wave energy as the wave reaches the harbor side. It helps redirecting the currents, therefore, it creates zones of controlled disturbance. Okay? Most importantly friends, breakwaters improve harbor entrance maneuverability, especially in case of very serious wind happening along the coastline. If the wave amplitude is also larger, sometimes it becomes very difficult to harbor a vessel of a large size, a cargo vessel essentially. So, breakwaters help us to reduce the wave amplitudes as the waves reaches the coast side or the harbor side. In general, it helps us improve harbor entrance maneuverability. Okay? Breakwaters reduce wave action in lee of the structure through combined mechanism of reflection and dissipation. Reflection alone, if you remember, we construct sea walls. Absorption alone, if you remember, we construct revetments. So, action together we construct breakwaters. Okay? They do both. They dissipate as well as reflect wave energy. The structural action of breakwaters are very simple, as I see from the geometry. They reflect and dissipate wave energy. It helps us reducing the wave amplitude on the lee zones. It is a massive gravity based system which is inertia dominated response. Okay? So, I can say that in most of these cases, predominantly the response of the system is static, not dynamic. Okay? Inertia force controls the response. Okay? They resist the loads by their weight, in other terms by their mass. Breakwaters play a very major hydrodynamic role in stabilizing the approach channels for harbors. Reef breakwaters are specific kind of breakwaters which are constructed near the shore to reduce wave energy by forcing wave breaking, inducing refraction and diffraction in the waves. Okay? It breaks the wave energy into different components. Once by reflecting, second by absorbing. Therefore, the wave force actually is broken and the amplitude is reduced by refraction and diffraction. Alternatively, friends, submerged sills are also alternates for reef breakwaters. They are constructed near shore. They interrupt on-shore sand movement and create discontinuity in the beach profile. Submerged sills are sediment control barriers. They are not wave barriers. So, one can quickly find the difference between a reef breakwater and submerged sills. Reef breakwater and submerged sills, they use as wave breakers, whereas they are used as sediment controls, not wave breakers. Okay? There is a functional difference primarily between a reef breakwater and a submerged sill. Typical photograph as you see here, you can say all of them are almost present here. A sea wall which is for a specific length. So, when the sea wall is constructed, you can see the sea wall is here. Okay? You can see the sea wall is turning. This is a sea wall cross section, you can see the length. So, this becomes a very perched beach because sea wall is constructed to maintain a rigid support all along the coastline. So, erosion is completely stopped. So, we can say this is a perched beach. So, on the other side of this you have got nourished sand because the transport of sediment happens from this part, gets deposited here because of wave and wind direction. Submerged sills are smaller in height, constructed, and where it allows the water to overflow, that is why it is called submerged sill, and they help in controlling the sediments transport. Okay? That is the main purpose of this. That is the main purpose of this submerged sill. They are constructed near shore, they interrupt onshore sand movement and they create discontinuity in the beach profile. Submerged sills are actually sediment controllers, not wave breakers. The other classification of coastal structure is training walls, which you see on the photograph. They control the direct flow of water and they create a navigation channel to this, okay, through this. It improves estuarine mooring and diverts the littoral drift away from the deposition zones. They are hydraulic control structures and not wave barriers. They are called training walls, training in sense they are controlling the navigation channel to act to a harbour or a coastal sector. Jetties or another structural systems constructed for stabilizing navigation channels. It reduces inlet shoaling and confines the tidal flow. The geometry and material used for jetties are essentially they are long and continuous like revetments. They have a concrete deck or resting on piles. They are constructed normal to the shoreline. Okay. Jetties are mostly permanent structures. Constructed to navigate or to stabilize the navigation channels, sorry, to stabilize the navigation channels. Okay. They confine the tidal flow. Usually, they are very long and continuous structures. They have concrete decks resting on piles. reinforced concrete deck. These are RC columns, which are also intermittently strengthened by stiffening beams. This is running for an entire length. So, it runs for a length. And the columns are constructed at equal intervals, and the facing, if this is a seaside, the facing will have shock absorbers. Okay, faced on the front on the seaside. So, they are usually concrete decks, permanent type construction resting on piles. Now, let us quickly see a summary of all types of coastal structures together, their structural action, material, etc. Let us talk about sea dike. The geometric form of sea dike is long, massive, trapezoidal shape, has a gentle seaward slope. The primary material used for constructing a sea dike can be sand and clay core. Alternatively, you can have grass, asphalt, stones, concrete slabs or armor to construct sea dikes. They are gravity based structures, low permeability, it reduces wave run up and prevents overtopping. The main function is flood protection of low lying hinterland along the coastline. It helps long term coastal defense. Sea walls are vertical or sloping walls, run parallel to the shoreline. They can be constructed with rubble masonry or even massive concrete or asphalt lining. They are rigid structures. They reflect waves. They have a very high vulnerability to toe scoring and wave slamming. If this is not handled properly, it may damage the seawall. They protect roads, promenades, buildings in urban coasts usually constructed along the coastline. Revetments or sloping walls facing natural shoreline constructed using stone or concrete blocks. They are very flexible systems. They are energy absorbing systems, unlike walls where they reflect waves. Okay? It reduces soil erosion along the coastline. The shoreline erosion control is more effective with minimum reflection when you have revetments constructed along the coastline. Bulkheads are vertical retaining walls. Bulk itself, you can say, it's a massive gravity based structure. You can use either steel sheet piles or concretes and use tie rods to connect them and use a filter cloth to make it more permeable. It acts as soil retaining structure. Wave action is secondary for bulkheads. It helps us retaining land. It is mostly used in harbors and marinas. Singapore has lot of bulkheads constructed along the coastal line where you got this Marlion line installed on the coastal line. Groins are unique kind of coastal structures constructed perpendicular to the shore. The cross section is trapezoidal, usually rubble mound systems. Sometimes people use sheet piles and concrete also to construct groins. It interrupts long shore sediment transport. It traps sand and preserves it from soil erosion. It is very helpful in stabilizing a natural beach. It controls erosion locally. Breakwaters, as the word says, water amplitude or wave amplitude need to be broken. It is a trapezoidal rubble mound construction constructed parallel to the shoreline. It can be continuous, can be detached. Usually quarry stones, concrete armor units are used to construct breakwaters. It reflects and dissipates waves. It helps reducing wave energy as wave approaches the coastline. It helps to create a calm lee zone useful for harbor protection wherever major harbors are constructed to facilitate the cargo handling and passenger handling. Breakwaters are subsidiary systems constructed along the harbors to prevent or to reduce the wave amplitude as they reach towards the harbors. So, it is a very essential unit to strengthen harbor protection and shoreline wave attenuation. Detached breakwaters are another type of breakwaters which are very short in length, near shore construction and non-connected, that is we call detached. Usually the cross section is filled with rubble bound masonry with low crust. It also helps in reducing wave height, induces tombolo formation. It is very helpful in beach protection with controlled sediment deposition. Reef breakwaters are another type of breakwaters which are submerged rubble mound system. They can be constructed using stone or concrete armor units. They help in breaking the wave forces by refraction and diffraction. They reduce wave energy before it reaches the shore. So, therefore, it helps in controlling erosion. Submerged sills, as the title suggests, they are low submerged barriers near the shore. Rubble mound construction. One can also use prefabricated concrete units to construct submerged sills. It helps interrupting the onshore offshore sand movement. It creates perched beaches and retains nourished sand. Wherever you have got scenic beauty of natural beaches, you will always find lot of submerged sills constructed on the beach side. Jetties are long structures constructed perpendicular to the shore, extending the offshore facility for cargo handling. It is a concrete deck resting on piles, rubble mound systems. It confines tidal flow, reduces shoaling effect. One of the major aspect and advantage of jetty is it stabilizes navigation channel and reduces the purpose of dredging. Training walls are constructed parallel and help in guiding the walls in estuaries. Usually concrete or rubble bound is used to construct training walls. It helps in controlling the direct flow and also controls sediment deposition. It helps in navigating the channels as they approach towards the harbors. It improves river mouth, estuary navigation. They are very useful in increasing or improving fish production. Chilka Lake in Odisha has training walls constructed, after which the fish production from the lake has improved quite a lot. Friends, as a summary, we say that no coastal structure is perfect. Engineering a coast is always a trade-off between protection, environment and economy. Coastal engineering solutions are not universal, they are local and regional. Every structure built along the coastline for coast protection alters the waves, current and sediment flow patterns. The challenge is choosing which impact is acceptable. Wherever we have got strategic structures constructed along the coastline, nuclear reactors, harbors, jetties, in fact even airports, floating airports constructed in Japan for example, wherever they are constructed along the coastline, it is essential that these structures should be protected from the natural hazard or the impact caused by the waves, current and soil erosion. So, we have seen quite a bit of type of coastal structures constructed for various purposes, their structural geometry and form, their materials of choice for construction, their layout and their merits and demerits and their applicability and the service lives. So, for more references and more reading, please refer to the book cited on the screen now, authored by me and Professor Jain, which is helpful in learning more about these kind of structures in detail. As a part of this course, we wanted the listeners to get introduced to coastal structures before we started designing them under special loads like fire, blast and explosion. Hope you have followed the previous and the sequel lecture completely. To understand more, for more information, please refer to the reference cited here, and should have any doubts or comments, please post them to the email at SwayamPrabha. We will be able to help you online, offline for clarifying your doubts and reinforcing your learning skills for the better. Thank you very much. Namaste.